Hi, I'm Bruce. Welcome to my Baptronics Mountain Labs here in Colorado. And today we're going to take a look at a resistor RDS43B. At least it's what it says according to the label on the back. There's something interesting about this unit though. The 43B is supposed to use 0.025% resistors. And when we open this one up, and we'll show you that in a little bit here, we saw that it used entirely 0.01% resistors. That would make this a much more expensive unit. In fact, it would carry the label RDS43A and would have been worth like $300 more when new than did the B. The B was 0.025% resistors, the A was 0.01. So I thought that was interesting. If you try to build a unit like this, utilizing, say, resistors you found on eBay, which are surplus resistors, if you found 0.01% in the values that you wanted, like in this case we use 10 1 ohm resistors, 10 ohm, 10 100 ohm, and 10 1000 ohm. So there's 40 resistors in here carrying a 0.01% tolerance. You'd find that when you went to buy those, that they would range probably in price each from about $5 to maybe as much as $20 a piece. So your price, if you could find the resistors at all, price of just the resistors alone would have run you somewhere between $200 and $800. Then you'd still have to, if you wanted to make this unit a similar unit where you could selectively combine those resistors to give you 10,000 combinations like this one does, then you'd have to have the switches as well. And these switches are very low resistance, gold-plated contacts, specially designed, and then somebody had to go to the trouble of assembling the whole thing and utilizing the proper wires and so on, so that you get low temperature compensation. And then you have a marvelous unit like this one. So, you know, say for something over $1,000 easily, you could imagine, and that's what these things ran. I mean, initially I think the B ran something like $1,600, and the A ran close to $1,900 in this particular model, the 4-decade model. It was utilized to simulate resistance thermocouple devices, also simulated load cell devices, and would also be utilized with in combination with a voltage source to provide precision currents and precision voltages for numerous other applications. So it's a very handy device to have on your bench, if for nothing else other than to just calibrate your meters or your scopes or whatever. Having a 0.01% resistance value at your fingertips is a very good thing on a bench. And if you can wrap all of that into an eBay surplus item that runs under $200, then you're doing something. I mean, it's a heck of a bargain when you take a look at it and think about it in terms of what it takes to build one of these things. I think I've seen Yokogawas, which are the more popular high-end units running thousands of dollars sometimes, that are listed at 0.1%, some of them. This is 0.01%. This unit is in very good looking shape. There is a very small scratch that's really pretty much not observable on the front panel. We do have one knob that has a a little bit of frosting around the rim. I don't know what caused that, some kind of chemical. But outside of that, the case is in very good shape. It's had a new paint job recently. And on the bottom, let's do it the right way here so we can read it. The bottom also is in very good shape. We've got 4 nice feet. And then it says right on the back of it here, General Resistance Incorporated model RDS43B, serial number 329, made in USA in Branford, Connecticut. So, well, as you can see, I opened up this Resistor unit, and I've got a real surprise out of this. I'm glad I opened it up, because this is supposed to be an RDS43B, but according to the resistors in here, they are all 0.01%. And the markings on some of them say RDS43M, which is odd. But 0.01% is more than double the accuracy of the 0.025 that they're supposed to be. I don't know if you can see the markings on there or not, but I will take a picture and make sure that the photograph reflects it. But these are all 0.01%. That would make them more than double the cost. And the unit claims to be a 43B. This is really interesting. I thought you'd take a look. The switches are supposed to have self-cleaning wipers. They were gold-plated. I may take the time to go ahead and clean them with a little deoxit. Well, anyway, thought you'd enjoy seeing the insides, and what a surprise that was. Okay, well, we've got this Resistor device connected up to this Fluke 8810. The 8810 has had a calibration within the last 6 months for resistance, so I feel confident here that we'll get some good readings. Right now we are reading the residual resistance at everything on 0. And we see that we're getting a 0.0385 ohm residual. So let's go ahead and dial in 1 ohm. We have 1 here. We see 1.038. Let's go to 2 ohms. 2.038. 3 ohms. 3.038. 4 ohms. 4.038. 5. 5.038. 6. 6.038. 7. 7.038. 8. 8.0375. Maybe we're calming down to a 7. 8.037. 8, 7, 8, 7, 8, 7, 8. I'm going to say 7.5. 8.0375. 9. 9.037. 10, 10.0367, 6767. All right, 10.0365. All right. Go back to our residual, and we are reading 0.0385. That's just where we were. Okay, let's go to 10 ohms. 10.038. 20. 20.036. 5. So we're flashing 6, 7, 6. More of a 6. We'll leave it at 6. 30. 30.0335. 40. 40.0325. No, 40.033. 50. 50.032. 60. 60.030. 70.02787. 78787878. I'm going to say 70.0275. 80. 80.027. 90. 90.025. No, 90.026. 5, 6. 5, 6. 5, 6. We'll say 5, 5. 90.0255. And 100. 100.0234343. 100.0235. Okay, and let's get back to the residual. 0.039. Okay, so we came up just a little bit. Let's go to the 100 ohm step. 100, we get 100.03335. Looks like it settled on a 4. We'll say 3, 4. Okay. Got to change range. Okay, we are 200 ohms. We got 200.03. 300.04. 400. 400.03. 500. 500.04. 600. 600.035. Well, it looks like she settled down to 0.3. All right. 700.02. 800.02. 900.02. 1,000.01. 1, 2, 1, 2, 1, 2, 1. I'm going to say 1, 5. So 1,000.015. Okay, and let's check the residual. Residual is on this range reading 0.04. Let's go to the 1,000 ohm step. All right, and we get 999.9676767. We'll say 6.5. I got to change range again. Now on the 20K scale, we've got 2,000 ohms going in, and we are flashing between 1,999.9 to 2,000. So I'm going to say 1,999.95. 3,000. I get 2,999.95. We're flashing 29.99 and 3,000. All right, so let's go 4,000. We've got 3,999.9. 5,000. 4,999.9. 6,000. That's 5,999.89. We'll say 8.5. 7,000. 6,999.898989. So 8,000 is 7,999.85. 9,000. 8,999.95. 10,000. 9,999.9. Okay. Let's pump these numbers in, take a look at the errors. Let's check that residual once more. We changed our range, that's why. Okay. Stayed at 4. Okay. Well, I had one bad point on the entire chart, and it's the very first point, the 1 ohm mark, which would be the hardest to get because it really draws upon the meter and everything else. It's the lowest ohmage to read. It's going to be the hardest to read. But I got 0.05% error, and if this is a 0.025% box, then that's double the error on that one resistance. All the rest of them fall below. In fact, great many of them are around the 0.01 or less. But because of that, I want to come back and revisit this 0 ohms. Right now we are reading 0.039, mostly 0.039. 0.039. And if I switch to 1 ohm, I got 1.039, which would be perfect. 0.039 to 0.040, but it seems to be, it's hanging on to 39 longer than 40. 0.039. 0.039, there we go. And 1.039. Now if I accept those readings, that'd be perfect, because that's 0. That's a 0% error. So use your own judgment there. It looks to me like it's doing quite well.